Hello everyone, my name is Matthew and today we'll be conducting lab 1 of 4 in creating simple circuits for our Arduino Uno. As for today's lab, we'll be conducting the binary counter lab to successfully create a 4-bit binary counter using our Arduino kit. As for our equipment today, we'll be using our Arduino Uno Type B USB connector, Arduino software, multiple male-to-male connector cables. Today we have 4 hot and 5 ground, 4 LED bulbs, 4 resistors at 560 ohms, and our breadboard. As for some background into this project, we have a voltage source coming from our pins feeding a 5-volt voltage into our resistors, out of our resistors, into the long legs of our LEDs. From there, the voltage will be fed through our LEDs and back into our voltage source. As for the digital pins we'll be using today, we'll be using pins 2 through 5 to facilitate the process of creating our binary counter. To explain a little bit more behind our counter, we are looking to illuminate LEDs to represent our binary code. So for example, if we wanted to represent a 0, then all LEDs would be shut off. As you can see here, all the ones in our binary code are similar to the LEDs that we want illuminated. As for some more explanation into our electrical map, we have a resistor in our breadboards that is connected to the desired Arduino pins, and from there those resistors will be connected to our long legs of our LEDs, feeding a voltage through our LEDs to the short leg of our LEDs and back into the negative terminal of the breadboard. After all is connected, we will connect the ground back into the ground for the Arduino. Hopefully by the end of this project we'll be able to use this potentiometer to create some variable control for representing these codes. So without a further ado, let's get building. To start our building phase, you can see here that I've already done the due diligence of snipping our resistors for a firm, snug fit into our breadboard. So the key here is to connect each resistor in a column for voltage to run through. We are going to connect each resistor 3 slots apart from each other. The key here is to connect each resistor where the tolerance band is facing away from us. After the resistors are connected, we'll connect the LEDs. As stated previously, we're going to connect the long legs of our LEDs into the columns where our resistors are. The key with this is to connect the long leg and the short leg 1 slot away from each other, like this. Once each LED and resistor are connected, we'll connect the live wires. So as stated previously, we're going to use pins 2 through 5 for our connections. Making sure that each live wire is connected into the right column. Once each live wire is connected, we'll connect the ground wires. The key with this is connecting each short leg of the LEDs into our ground wires. Now placement in this negative terminal doesn't quite matter as long as they're all connected in the ground terminal. Now once each ground is connected, we can connect the ground wire from the breadboard to the Arduino. Awesome. Now our circuit is complete. Let's get to coding. Programming phase. Once we've set up our circuit, we can start programming. So first off, we want to start setting our variable pins. We can do that by setting our int initial variables. Here we'll just set each pin and their corresponding number. Make it easier, I'm just going to copy and paste. Making sure that we're using each number that we discussed previously. Oh, sorry. Then from there we can start our setup. For here we're going to use the pinMode variable, setting our desired pin, and our output. And we're going to copy and paste just to make it a little bit more easier. Then from there we can start setting our loops. Now we want to test this to make sure that each light turns on, and in order to do that all we have to write is our description where almost forgot. It's always nice to set up notes so we know what is what. For our loop, in order to test each light, all we have to do is put in our digitalWrite command and select our desired pins. So in order for our LEDs to turn on, we want to set each output to high. High means on and low means off. We're just going to copy and paste just to make it a little bit easier for us. And from there, we can we can verify. You want to save it as a file name. We'll do bin counter. Once everything is verified, it gives us the green check. We can upload, and all LEDs should turn on. You can see here all LEDs are on. Awesome. Let's go back to our Arduino, and now we can set all of our counters for what we need. Once we figured that all the LEDs turn on using this digitalWrite line of code, we can start to set all of our positions for the numbers that we require. As you can see here, I just copy and pasted this line of code for each number, and I changed each high and low to represent the numbers that we desire. So after doing all of that, we're going to set our delay time so we can see each LED light up where it's legible and it's visible, so we can see our results. So from here we just set our initial variable. We can set our initial variable, delay variable, sorry, to say wait. And then set this to 1,000 milliseconds. And then from there we can just input our delay time to wait. Oh. Then from there we can just copy and paste each delay time for each variable that we have for each number. It's a little tedious, but it gets the job done. Then from there, we just verify with the green check. Then from there, we just upload. Awesome. Then from there, if we switch to our camera, you can see that we have our binary counter. Isn't that cool? I think so. As you can see, if I can add a little bit more light, there you go. Oop. So it'll work with me. As you can see here, it's cycling through our inputs, and it's describing each number in binary. And it's cycling through our delay time where you can see each number clearly and concisely. So that's 0, 1, 2, 3, 4, 5, 6, and so on. Awesome. Now make sure to follow for part 2, where we try to implement this potentiometer to enact some variable control. I hope you all have a wonderful day. Bye.